Hello, this is a summarized version of the master thesis, Automatic Recognition of Vocalizations in the Lusitanian toadfish. This thesis is made in two parts. The first part is about making a model capable of distinguishing between vocalizations of individuals and also to distinguish between vocalization types. And the second part is about metadata and how it compares to vocalizations. For example, if there's more vocalizations during which time of the day and during high tide or low tide and such. The species in the study is called Holobatrachus didactylus. The English name is the Lusitanian toadfish. In Portuguese, it's called the Charroco ou peixe sapo. It's about 1/2 meter in length. It's solitary and it's found in shallow, low visibility waters, and it's known to produce a variety of noises. It makes a boat whistle used to attract both females and to deter intruding males. It does grunts, croaks, and double croaks, and other less frequent sound combinations. The model used to identify the sounds, analyze the sounds, is called the hidden Markov model. It's a chain between states and probabilities that go from each state that represent transitions, and sometimes it has end nodes. In the hidden Markov, the chain is invisible and we can determine the output. And this can be used to model speech and to do speech recognition, where the features of the sound are modeled in a hidden Markov chain. The objective is to develop a system that can detect mating vocalizations, both whistles, and to allow individual identification from their vocalization. So we recorded 13 days in this paper. Not we, they. And there was about 30,000 boat whistles, 23 croaks, and 24 double croaks and 77 grunts, and also some other samples that were or brought from other previous studies. The system performed well identifying both whistles, but badly identifying other types of calls. It has a 98% identification rate for both whistles, but a 10% rate for other vocalizations. And in both whistles, it fails when there is more than one boat whistle overlapping, which happens sometimes when males start to argue with each other. But for predicting which individual is making the boat whistle, the system is rather good with a 95% correct rate. As you can see in this confusion matrix for the 13 individuals, most of the time it guesses which individual is making which sound. And this system was also capable of measuring the length of the boat whistle when compared to a human doing it. And it was also revealed that when it was done using different parameters for training, that the essential signal information lies within the 20 to 1000 Hz range. The second part of the study, like I mentioned before, is about correlating the parameters of light, water level, temperature, and location of the nest with the amount of vocalizations being observed. And there are two groups of nesting fish being compared: the infratidal, that have nests always underwater, and the intertidal, with nests that are above water during the low tide. In the photo here, you can see that this area here is the intertidal area, that sometimes is above water, sometimes below water. The toadfish appears to have a circadian vocalization rhythm that with increased activity at night, and you can see a peak here. It's around 6 to 8 is when they are most vocal, 6 to 8 a.m. But for the intertidal fish, the pattern changes, and what we observe is actually they follow the tide. When the tide is high, they vocalize more, and when it's low, they don't vocalize. And this is quite different from the other group. There's no hypothesis suggested on why some males nest in the intertidal zone if they're not able to vocalize as much. And also the circadian rhythm observed in the infratidal nests could also be associated with light, temperature, and lack of disturbing human activity. That is less on those hours that they vocalize more. Fish positioned 10 meters away from each other adjust the vocalization to form a steady alternating chorus. But sometimes males synchronize their vocalizations for 3 or 6 boat whistles in what is thought to be like a rivalry contest. This fits the idea that both whistle vocalization serves both as a warning to other males and to call females. And that's about it. Thank you.